So this last video is going to look at measuring changes in heat. So let's first start by looking at this picture of a styrofoam cup down on the bottom right of the screen. And that's what we would call a calorimeter in chemistry. It's basically just an insulated device that we could use to measure changes in heat being absorbed or heat being released in a chemical or physical process. So a styrofoam cup is just one example of a calorimeter. In the specific heat lab, we're going to be looking at using a soda can as a calorimeter to measure heat absorbed and released. All right, let's start talking about enthalpy. If we look at these two reactions up top, you have AB plus heat yields A plus B. The heat is written on the left-hand side of the arrow. Remember, if you're on the left of the arrow, you're a reactant. In the second equation, you have C plus D yields CD plus heat. The heat is on the right side of the arrow, meaning it's a product. So what we need to look at is where the heat term is written in each of the equations. And just in general, any equation that has the word heat or energy in it is called a thermochemical equation. If the heat is on the left of the arrow, so here's our arrow, if we're on the left, it's going to be endothermic, so heat must be added. And when we write the word heat or energy on the product side, it indicates that it's an exothermic reaction or heat is being released. In a chemical reaction, the delta H is also known as heat of reaction. It's equal to the heat of the products minus the heat of the reactants, or the potential energy of the products minus the potential energy of the reactants. We're going to look at this more in kinetics moving forward. But what we do need to do is at this moment take out reference table I and open up to our heat of reaction table. It's going to show us the amount of heat released or absorbed in any reaction. Delta H is measured in a unit called kilojoules, kJ. Remember, kilo is just the prefix, J is the unit coming off of table D for heat or energy. So when a reaction is endothermic, we're going to write the word heat on the left-hand side. And the sign of delta H will be positive because heat is being absorbed. So this delta H is the products minus reactants. The products is going to be a larger value than the reactants. So that in the end, we end up with a positive value for delta H. If you look on the very, very bottom of table I, you'll notice it says, there's a little asterisk and it says minus sign indicates exothermic reaction. So if minus is exothermic, when you see a positive delta H and the values on the right-hand side, that means it's endothermic. So exothermic is just the opposite, a reaction that releases heat. The word heat will be written on the right-hand side of the arrow, showing it's a product, and delta H will be negative. So the heat of the products minus reactants would be a negative number. Okay, some things to keep in mind. First of all, the reactions are occurring at standard pressure, but not standard temperature. The temperature for table I is 298 Kelvin. Something to keep in mind. And a question, when you see 298, you might want to tune in the table I. The heat of reactions, the delta H values, are all listed on the right-hand side column of table I. And like I mentioned, the asterisk will be there to tell you that minus sign is exothermic, so you don't have to memorize that, which is pretty nice. So here's a reaction right off table I. This is the first reaction on the chart. We have methane gas combustion. We have, if you look at the delta H, you get negative 890 kilojoules. So let's say you had to write the heat term into the reaction. Since it's negative, it means it's exothermic. Exothermic, the heat is going to go on the product side or the right-hand side. So you show the equation. You put the heat amount all the way on the right. You could also write plus heat, that's another way, or plus energy to show that. But if we're going to put it in, even though the heat is negative, we're going to put it on the right-hand side to show that heat's being... Okay, let's jump down the chart. Now we're going to look at the 10th reaction on the chart. So we have nitrogen and oxygen gas. If we look at this reaction, the delta H is positive 182.6. Since it's a positive value, that means it's endothermic. Endothermic reactions, we're going to write the heat term on the left of the arrow. So endothermic reaction is absorbing energy, so that means you have to take it in for the reaction to occur. So put it on the left side, on the reactant side. Okay, a couple other things to keep in mind. You could be given an equation and asked if it's endothermic or exothermic. So for each of the examples, all that's happening here is you would look at the equation, find it on table I, look up the value. If it's a positive value, endothermic. If it's a negative value, exothermic. So sometimes the question will just ask you, is it exo or endo? When you see that, think to use table I. If it's exo, negative delta H, endo, positive delta H, and again, just use the asterisk on the bottom to help you. Also, there are questions that ask which one release energy. We should always underline release energy, annotate, annotate, annotate. Releasing energy, you should write exothermic. Exothermic means delta H is negative. So you have to look at each of these reactions. There are a couple of reactions on the bottom where it shows you like an arrow with H2O over it. That means it's dissolving in water. And you're looking for one of the reactions where it dissolves and it produces a negative delta H. That would be lithium bromide. Okay, also with table I, something to keep in mind. So let's look at this first reaction up here. N2 plus 2O2 gives you 2 NO2 gas. They could ask you in a question how much energy would be released for 1 mole of gas. So let's say they give you the same reaction, but they only say that you want per mole of NO2. Or if you just had 1 mole of NO2 instead of 2 on the product side, you would divide the delta H by 2. If it was 3 NO2s and you had to get 1 NO2, you divide by 3. So you look at the amount of product that you have, and if you only wanted 1 mole, you divide by whatever number is in front to figure out what it would be per mole. The other thing is the reaction could be reversed. Like this reaction is N2 plus 2O2 gives you 2 NO2, but let's say it was reversed and it started with the 2 NO2 arrow N2 plus 2O2, then you would just switch the sign of the delta H. So instead of being positive 66, it would be negative 66. So if you switch the equation order, meaning the products become reactants, the reactants become products, you just switch the sign of the delta H. And lastly, if the value of moles changes in front, like here it was 2 NO2, but if it changed, let's say it went to 4 NO2, well then you would just double the delta H. So whatever you do to change the amount that's written in the equation on table I, you do the same thing to the delta H. Okay, and lastly, we just need to introduce this new word, vocab word, entropy. Entropy means randomness or disorder. And in nature, we favor things that are lower energy and higher entropy. Like we favor things that produce more disorder, like a messy room. The phase that has the least entropy or the least disorder would be a solid, right? Solid particles are arranged in nice geometric pattern. So a gas would have the most entropy, solids have the least. That's just something that they typically will ask, like which one has the greatest entropy? Gases. So here's a picture for you. You see on the left-hand side, the room is nice and organized. That's pretty organized, so low entropy, but here on the right, lots of entropy or high levels of disorder in the messy room. Here's a picture of solid, liquid, and gas. We could see how ordered the solids are, so they have the least amount of entropy, and gas are all random, so they have the most entropy. So as you go from a solid to a liquid to gas, your entropy will increase. And here's just a nice little summary for you of this information that we've talked about today. Exothermic means to release heat or heat's leaving. The delta H will be negative, and heat will be written on the right. When it's endothermic, it means heat's being absorbed or taken in. Delta H is positive, and you write it on the left.